Hello dear students, welcome back to EduHunt online teaching platform. At this section today we are going to discuss about elementary geometry, which is a part of 9th class mathematics. Have a look at fundamental concept of geometry. So firstly, who is the father of geometry? So who is the father of geometry? Euclid. So he was a Greek mathematician, and also he worked on Euclidean geometry. Am I clear? Who is the father of geometry? So Euclidean. He was a Greek mathematician and also worked on Euclidean geometry. Am I clear? So in that geometry, first point is space. So what is a space? In a geometry, space refers to the unbounded three-dimensional region where all geometric objects exist and can be located. So clearly we need to understand. So in a geometry, space is a three-dimensional region. That means it has length, width and height. So any three-dimensional region contains length, width and height. So here three-dimensional means it has length, width and height. So here what I am given, all geometric objects exist and can be located. So that means the space is infinite. Infinite means it extends without end in all directions. So it is it was not end in all direction. Am I clear? So it contains all points, lines and plane. So that is the main definition of space. So it contains a space is a three-dimensional region. It contains all points, lines and planes. Am I clear? So that is called space. So next one is plane. A plane is a two-dimensional surface. So what is the difference between space and plane? It is a two-dimensional surface, but space is a three-dimensional region. So a plane is a two-dimensional surface that extends infinitely in all directions. So it can be extended infinitely for all directions. Am I clear? So two-dimensional means in the sense it has length and width but not thickness. So plane doesn't have thickness, but it is length and it has length and width. Am I clear? So next point. What is a point? Coming to the point. So what is a point? A point is a most basic element in a geometry representing a specific location. It has no length, width or thickness. So it is considered as a point. So this is in a geometry, it is represent a specific location. So let me take in, this is a point. Am I clear? So it has have not a length, width or thickness. Am I clear? So next one, coplanar points. Coplanar points are points that all lies on the same plane. So clearly we need to understand. Let me take in, this is a plane. This is a plane. Am I clear? So here what I am given, coplanar points are points that all lies on the same plane. For example, here what I am taken, 5 points taken. So these 5 points are lies in the same plane. It is called coplanar points. So next point is non-coplanar points. That means non-coplanar points are points that do not lie on the same plane. So clearly we need to understand this is a plane. For example, 3 points or 4 points. 4 points lies in the same plane. 2 points do not lies on the same plane. So outside. So inside how many taken? 4, outside 2. So all points do not lie on the same plane. This is called, these points are called non-coplanar points. That is the difference between. What is the coplanar points? All points lies in the same plane. So that is called coplanar points. All points do not lies in the same plane. That is called non-collinear point, non-coplanar points. Am I clear? So next point, collinear points. When 3 or more points lie on the same straight line on a given plane, they are known as collinear points. So what I am given, when 3 or more. So 3 or more points lie on the same straight line on a given plane, they are known as collinear points. For example, let me take in 3 points here. Or 3 or more, 4 points also. So these 4 points, more than 3 means at least 3. More than 3 means at least 3. 3 or more. So at least 3 points lie on the same straight line on a given plane. They are known as collinear points. So what is collinear points? So 3 or more points lie on the same straight line is called collinear points. So next one, non-collinear points. Non-collinear points are the points that do not lie on the same straight line. For example, so let me take in 4 points in a plane, but these do not lie on the same straight line. It is called non-collinear points. That is the difference between collinear and non-collinear. But in geometry, collinear points are very important. Am I clear? So what is collinear points? 3 or more points lie on the same straight line is called collinear points. So coming to the next point, line. This is very important. So line. A line is a straight path. A line is a straight path that extends infinitely in both directions. It has only length and do not the thickness. So clearly we need to understand a line is a straight path, just like that. A line is a straight path. A line is a straight path. Am I clear? So clearly we need to understand it is extended infinitely in both directions. It is extended infinitely both directions, just like that. So this is called line. Am I clear? It has only length. It contains only for length, but do not width or thickness. It is not no width or thickness. It is contains only for length. Am I clear? So actually line can be represented as, so this is a line AB. Let me take in line. Okay? Clear? It is represented by AB, but here double arrow taken. This is called line. Am I clear? So AB, this is a double arrow. Okay, double arrow. It is represented by AB bar, but it can be represent double arrow. Okay, nothing but so already mentioned it here in both directions. So a line is a straight path that extends infinitely in both directions. It can be extended infinitely both directions means, so they can be represented with arrow both sides. So next one, line has no endpoints. It is clear, line has no endpoints. A line, this is a line. Okay, a line does not have a definite length. So a line does not have definite length. So line cannot be measured. Am I clear? A line cannot be drawn on a paper. So if it is taken paper, so a line cannot be drawn. So because it is infinitely in both directions. It is extended infinitely both directions. So line cannot be drawn on a paper. Am I clear? Next one, a line is represented by AB double arrow bar. Okay, next point, line segment. What is the difference? Okay, let us go to next point, line segment. What is the difference between line and line segment? So clearly we need to understand a line extends infinitely in both directions, but in that line segment, a line segment is a part of a line with two defined endpoints. Two defined endpoints, just like that. A and B are defined endpoints. Am I clear? So this is called line segment. So line segment is a part of line with two defined endpoints. AB are defined endpoints, nothing but it has a definite length. So clearly we need to understand it has a specific length that can be measured. So AB can be measured, but in that line cannot be measured. So measured means AB how many units? You know that. So if it's given 10 centimeters AB, that is called line segment. AB length 10 centimeters. So this is called measured. It is definitely measured. So for next one, a line segment has two endpoints. Am I clear? A and B are endpoints. Next one, a line segment has a definite length. So if it is given 10 centimeters, you can draw it. Nothing but a line segment can be drawn in a paper. Am I clear? So next one, definite length. Next one, a line segment of a given length can be represented on a paper. So it can be drawn in a paper. Next one, line segment AB bar is same as the line segment BA. So AB equals to BA. Suppose if it is given 10 centimeters AB, BA also 10 centimeters. Am I clear? So AB equals to BA. So clearly we need to understand line segment AB bar. So nothing but it is two endpoints and also defined length. Okay. So AB equals to, it can be written BA also. BA. Okay. It can be represented as line. So nothing but bar. AB bar equals to BA bar. Am I clear? So line segment is a part of a line. Here. So it is a part of line. So clearly we need to understand. So line is extends infinitely in both directions, but in that line segment, it is a specific endpoints. Nothing but it can be measured. Am I clear? So line segment contains two endpoints, and also line segment has a definite length, nothing but it is countable. Actually AB is a countable, but in line uncountable. Am I clear? So what is array? Array is a part of a line that has one endpoint and extends infinitely in one direction. So clearly we need to understand. So what is array? Array is a part of line. Array is a part of line that has one endpoint. So one endpoints and extends infinitely in one direction. So infinitely one direction. This is called ray. So here a ray has one endpoint. So only ray has one endpoint. That is that one. It is a line segment extended. So it is line segment extended. A ray does not have a definite length. So ray and line does not have definite length. So a ray cannot be drawn on a paper because it is a infinitely in one direction, nothing but it is extended infinitely in one direction, nothing but a ray cannot be drawn on a paper. So ray, it can be denoted as AB bar, one direction only taken, only it can be represented as one arrow, because that arrow indicates extended infinitely in one direction. Am I clear? This is called ray symbol. But AB and BA are different. So if you take an AB, it is not equals to BA. Am I clear? So ray AB and BA are different. This is very important point. Am I clear? Next one, intersecting lines. When two or more lines cross or meet each other in a plane, the lines are called intersecting lines. So clearly we need to understand what I am given. When two or more, for example, two lines cross or meet in each other in that plane, so that line are called intersecting lines. So these two are lines intersecting. So these are called intersecting lines. Am I clear? So two or more lines cross or meet each other. So in a plane, the lines are called these here AB, two lines intersecting each other. Okay, these two lines are called intersecting lines. Next one, concurrent lines. When two or more lines that intersecting at a single or common point, this point of intersection is called the point of concurrency. So just like that. This is called concurrency. So clearly we need to understand. So what is the concurrency? When three or more. So but here two or more intersecting in an intersecting line. But if three or more means you should make at least three or more than three intersecting at a single or common point. So this point of intersection is called point of concurrency. These lines are concurrent lines. Am I clear? So have a look at worksheet number 1. So in that in worksheet number 1, what I am given, matching the following groups. They can be divided into two groups, group A and group B. Group A, what I am given, space, plane, intersecting lines, collinear points. In group B, what I am given, same line, one point, lines, planes, and fourth, flat surface. So already told you the definitions, already explained. What is a space? So clearly we need to understand. So once I am explained that, yes, space is a three-dimensional region. Am I clear? It contains all points, lines, and planes. So clearly we need to understand already it contains all points, lines, and planes already there. Okay na? So space contains lines, planes. So A is it is matched with third one. Okay. So only one option is given. So tick the third option directly. So remaining I have to explain that. So next one, B is a plane. So plane means what? Already explained that. What is a plane? So plane is a two-dimensional surface. So it contains a definite length, width, and thickness, and also it is a two-dimensional surface. That is a very important word in that question. So clearly we need to understand. So what I am given here, plane, nothing but a flat surface area. Am I clear? Flat surface area. So here B is matched with fourth one. Next one, intersecting lines. Already explained that. Intersecting means what? Two or more lines intersecting at one point is called intersecting lines. So it is matched with, so C is matched with 3. 3 or 2? Okay, 2. So 1 point. So intersecting lines. Next, collinear points. Collinear means what? So 3 or more points lies on the same straight line is called collinear points. So here D is matched with 1. So which option is right answer? A3, B4, C2, D1. So A3, B4, C2, D1. Option 3 is right answer. Am I clear? Let's go to question number 2. Given two distinct points, there are so many lines that pass through them. Option A, true. Option B, false. Option C, can't be obtained. Option D, none of these. So through any two distinct means different points. So only one line can be drawn from the distinct 2 points. Am I clear? So is it possible so many lines that passes through? No. Only one line passes through in 2 distinct points. So nothing but given statement is false. Option B is right answer. So clearly we need to understand. So given 2 distinct points are given. So let me take in AB are 2 distinct points. So through any 2 distinct points, only one line can be drawn. Only one line can be drawn from the distinct 2 points. Am I clear? So option B false. Nothing but a given statement is wrong. So not possible so many lines that passes through. Only one line is passes through distinct points. Am I clear? Option B right answer. So let's go to question number 3. If X represents the number of lines joining 2 points at time, then the formula for finding X is option A, n into n plus 1 by 2, option 2, 2n into n plus 1 by 3, option 3, n into n minus 1 by 2, option 4, n into n minus 1 by 3. So this is a direct formula. Option 3 is right answer. So X represents here what I am given, number of lines joining 2 points at time. So clearly we need to understand. So n into n minus 1 by 2 is a number of line joinings points at a time. So for example, if it is given 3 collinear points, for example, covariance, so only one line can be drawn from 3 collinear points. But in that question, for example, if it is given 3 non-collinear points, so how many lines can be drawn at a time? 1, 2, 3. So here n stands for number of, so here n stands for what? Number of lines. So clearly we need to understand. So X represents number of lines, but here n stands for number of points. So if it is given 3 non-collinear points, so what is the formula? 3 non-collinear points, n equals to 3. N equals to 3. So what is the formula? So number of line joining points. Line joining points, number of lines, nothing but what is the formula? N, nothing but 3 into 3 minus 1, 2 by 2, 2 cancel, so 3. So if it is given 3 non-collinear points, how many line joining segments can be obtained? So 3 into 2 by 2, that is a formula. Option 3 is right answer. Suppose if it is given 4 non-collinear points, suppose 4 non-collinear points, how many line joinings are obtained? So clearly we need to understand. N equals here what I am given, 4 non-collinear points. So how many lines can be drawn? 1, 2, 3, 4, 5, 6, total 6 with respect to diagonals. So what is the formula? N equal to 4 given, 4 into 4 minus 1, 3 by 2, 2 1s are 2, 2s are 2 into 3, 6, but here also got 6, 1, 2, 3, 4, 5, 6. So this is the best formula. So line joining segments, if it is asking, so directly can use n into n minus 1 by 2. Here n stands for what? Number of non-collinear points. That is very important, non-collinear points. Am I clear? Let's go to question number 4. If X represents number of lines through a given point P in a plane, then the value of X is. So clearly we need to understand in that question what I am given, X represent number of lines through a given point P. So let me take in P is a given point. So how many lines can be drawn from the points? So from the through points, it is not from through points. So option A 1, option 2 less than 10 power 10, third option 10 power 10, fourth one infinite. So if it is given a point in a plane, so they can be drawn infinitely number of lines, infinitely number of lines. Am I clear? So in that question, which one is right answer? Option 4 is right answer. Am I clear? Number of lines through given point is infinite. Am I clear? Option 4 is right answer. Let's go to question number 5. The simplest of the all geometrical figures which has no size but has only position is called. So clearly we need to understand in that question what I am given, the simplest of all geometrical figures which has no size but has only position is called point. Option 3 is the right answer. Point. This is there is no size, no width, no height, no thickness. Am I clear? So only one position, but it has only one position, that is called point. Option 3 is right answer. So let's go to question number 6. 3 or more points in a plane are said to be collinear if they lies on the same line. Lies on the option A, same plane, same line. Here what I am given, first option same plane, second one same line, third one different lines, fourth one none of these. So what is collinear? If it is given three or more points, they are lies in a same straight line is called collinear. So clearly, so 3 or more points in a plane are said to be collinear. That means if they lies on the, nothing but given points lies on the same line. Option 2 is right answer. Same line. It's not a same plane. So which one is right answer? Option 2 is right answer. Question number 7. So given figure. So in that given figure, point P is called option A, intersecting point. Option 2, point of concurrency. Option 3, collinear. Option 4, plane. So intersecting point means 2 or more. So 2 or more points intersecting at a same point is called intersecting point. So clearly we need to understand in that question. So given points are points are concurrency because they can intersect at a same point. It is called concurrency. So given points are concurrency because, so already told you the definition. So when 3 or more lines that intersect at a single or common point, this is single or common point, these points of intersection is called a point of concurrency. Am I clear? So 3 or more, already given 3 or more lines intersect at a single or common point. So these points of intersection is called point of concurrency. Am I clear? So in that question what I am given, so in that 3 or more, okay. In the given figure, point P is called point of concurrency. It is not an intersecting point. Okay, intersect means 2 or more points. But here already concurrency, P is concurrency, 2 or more points intersect in common or a single point. The given points are called point of concurrency. Option 2 is right answer. So question number 8. In the given figure, PO and QR. So what I am given, PO, QR, collinear, non-collinear, point, space. So clearly we need to understand here P, O are non-collinear points because 3 or more points. So here 3 points given. O, P first given, P, this is a P, this is a O, and Q here. Okay. So these 3 points these 3 points do not have a common line. Nothing but so 3 are here. What? How many points given? 3 points. What is the names? P, O, Q. So given points do not lie on the same straight line is called non-collinear points. Am I clear? So 3 points lies on the same straight line is called collinear points. So here what I am asking, in the given figure, POQ. So POQ are non-collinear points because in that question, so 3 points POQ do not lie on the same straight line. It is called non-collinear points. Have a look at question number 9. Which one of the following is a simple closed curve? So here 1, 2, 3, 4, 5. So 5 options given. So in that following option, which one is a simple closed curve? So here in that question, what is simple closed curve? That means begins and ends with the same point and do not intersect itself. That is called simple closed curve. So clearly we need to understand. So begins and ends with the same point, but here not. Here begins, here ends. So first one, eliminate them. So in that second one, for example, in the second one, what I am given, rectangle. Suppose here taken starting begins, it is ended with the same point. It is called simple closed curve. Option 2 is right answer. Third one also, it is begins, it is ended. It is begins and ends with not a same point. It is also not a simple closed curve. It is also not a simple closed curve because it is not intersect. It is not intersect. So if it is given only for circle, so begins and ends with same point. But here what I am given, so here a chord also given. So that means it is separated. Nothing but do not intersect itself. So fourth one also wrong. So fifth one, so begins and ends with the different points. It is also not a simple closed curve. So what is simple closed curve? Begins and ends with the same point and do not intersect itself. That is called simple closed curve. So option 2 is right answer. So let's go to enrichment worksheet. Classify which of the following are open shapes and closed shapes. So in that following figures, what I am asking, which one is open shape and the closed shapes? So here how many figures given? A, B, C, D, E, F, G and H. Total 8 figures have been given. So in that question, what I am asking? So open shape and the closed shape. So clearly we need to understand. So what is the definition of open shape? Yes, open shapes means they do not begin and end at the same points. So what is the open shape? They do not begin and end at the same point, means beginning and ending were different. So what is a closed shape? They begin and end at the same point. So beginning points, ending point are same. It is called closed shape. Beginning points and ending points are different. That is called open shape. But in that question, what I am asking? Open shapes and the closed shape. So you can write the answer directly. So clearly we need to verify it. So first one given figure is clearly it is a open shape because beginning point and end point are different. It is called open shape. So B, it is a closed shape because beginning point, starting point both are, for example, it is beginning, ending also be same. So nothing but it is called closed shape. So C, so beginning point and end points, beginning and end are different. It is called open shape. So beginning and ending, so begins and ends are different. So that is called open shape. Next one, D. So here clearly we need to understand beginning point and end points. Beginning points and end points are same. It is called closed shape. So next one, E. Beginning point and end points are different. This is a different. Beginning and ends with different. This is called open shape. So F, beginning point, circle, beginning point and ending points, begins and ends with the same point. Nothing but it is called closed shape. G, begins and ends with different points. It is called open shape. And finally H, so begins and ends with the same point, begins and ends with the same point, just like that, begins and ends with, this is a pentagon, begins and ends with the same point. It is called closed shape. Closed shape. Am I clear? So next question is, how many edges does the given figure have? So given figure have how many edges? So clearly option A 12, option B 5, option C 6, option D 8. So clearly we need to understand. So clearly this is a pyramid shape. So what I am given here, pyramid shape. So base in that pyramid base shape is a square. Nothing but it will be considered as A, B, C, D. Okay. So in that edges all are connecting in the one point, that is called E. What I am taken E. So how many edges does the given figure? So how many edges? First one AB is a one edge, next one BC, next one CD and DA. So in that bottom square contains 4 edges, and again AE also one edge, next one BE also edge, next one CE also edge, and DE also edge. Total given figure contains how many edges? 8. So option D is right answer. 1, 2, 3, 4, 5, 6, 7, 8. Am I clear? So next question, number of dots are common to both the circles and the triangles is. So clear. Option A 3, option B 23, option C 11, option D 12. So clearly we need to understand. So these two geometrical figures intersect each other. So but question what I am asking, number of dots common to both circle and triangles. So clearly we need to understand circle and triangles are intersect each other. So this is called intersection part. This is called intersection part. So in that intersection part, how many dots given? 1, 2, 3. So both circle and triangle contains how many common dots? 3. Option A is right answer. So this is a common intersection part. That is called common part. Am I clear? It is also easy. So rest of the questions I will explain you in my next class. Thank you for watching my videos. Jai Hind.